Carl Summer, president of Reliable EDM, has a wealth of machining experience. Having worked as a machinist, tool and die maker, foreman, tool designer, and operations manager, Carl now shares with you from his wealth of experience.
Let us look at some examples of wire EDM cutting. The first example we have is this Texas Tech symbol that we're making for their football team. And what we have in the machine is this big T, and we're making that a cutout in there so the small T will fit into it. Now there we have the nozzles up in the air. This is not the ideal cutting condition. The ideal cutting condition for wire EDM is the top nozzle and the bottom nozzle to be on the workpiece. And the reason we do this is so they have maximum flushing pressure, because we have to get rid of the eroded particles. However, if we showed you this example, you wouldn't see any sparking. So what we have then is the nozzle up in the air, and the first example is with no flushing, and the second example is when we put on the flushing. The second example we have is this Reliable EDM showpiece. And here you can see the wire electrode along the whole surface and sparking occurring. Now we're doing the first one with no water in the tank, just the water rolling along the surface. This again is not the ideal method. This is a machine that is totally submersible. The second cut, you'll see the ideal way to be skim cutting, where we have this filled with water, and there it is skim cutting. But you don't get as good picture in the second one as in the first one. So that's why we have shown you both ways of how we're doing our skim cutting. There are rapid electrical impulses between the wire electrode and the workpiece. Now let's examine what happens between the on and off times of this here sparking process. When the sparking process is complete, the melted workpiece material is cooled and pressurized dielectric fluid removes the eroded particles. A filter removes the EDM chips. Now you were creating chips over here. So now you have this, going back again to this drawing over here. Here we have pressurized dielectric fluid being pumped through these flush cups to, as you see over here, and the pressurized fluid removes the EDM chips. Here's another drawing of this here path of wire electrode generated by CNC automated computer system. Here's the pressurized fluid on the top and the bottom, which escapes, and the spark erosion causes the material to be eroded. The material removed is cooled by a dielectric fluid, and that's another feature of the dielectric fluid. It cools the material. Remember, if there's too much heat, everything expands and you lose accuracy. So there's a chiller on these machines to keep the temperature of the water at a certain temperature. This is extremely important for accuracy. The gauge of wire ranges from 0.001 thousandths to 0.014 thousandths. In millimeters, it's 0.025 to 0.357 millimeters. In our shop, we generally go down to 4 thousandths thick wire. But we need to remember, when you use these smaller wires, like 4 thousandths or 6 thousandths or 8 thousandths, you cannot put that much electrical current into it. So it's a slower cutting process, and it becomes more expensive. Another thing we need to remember also, that the wire electrode never contacts the workpiece, that there's always a gap. Now, depending upon the energy of these sparks determines the surface finish of the EDM parts. Now, we can take a rough cut and you will look and say, well, that looks very good. Now we can make these sparks very minute. And that's what we call skim cuts. We go over and over again, and we can get practically a mirror finish that way by having these sparks very, very small, very little amount of energy, So these pits are not as large as these. They get smaller and smaller. And you can see that we get practically a mirror finish with wire EDM. I'd like to show you an example of the finish that we get with a rough cut. Now this is a 40-inch part that I'm pulling out over here. Now just take a look. I'm going to put a flashlight at the other end so you can take a look at it.
That's good. It's amazing because from this angle it looks really dull. It looks really, you're good at.
We have examined the wire EDM process, how it cuts, how it machines. And remember, wire EDM can cut any electrically conductive material. Even this tool bit has been machined with wire EDM. This is carbide, and it's been silver soldered onto this metal shank. It can cut also hastelloy, inconel, and other exotic materials. Extremely fine finishes of below 15 RMS can be produced with wire EDM. Even in the so-called rough cut that we demonstrated before, this part, we will get an excellent finish. This fine finish is present even when very large parts are cut. In other cutting operations, such as lasers and abrasive water jet, the larger the part, the rougher the finish. The reason for the smooth finish with wire EDM is that the wire electrode goes through the entire part and spark erosion takes place along the entire wire electrode. For instance, on this part, the wire electrode went through the entire part, not like in laser, which cuts with light, or abrasive water jet, where the abrasives come on the top and then it sort of mushrooms out. And also laser cuts with light and the light mushrooms out, but not with wire EDM. Wire EDM, the entire electrode goes through, and that's why it can cut so accurately. To learn more about this amazing process of EDM, there's the complete EDM handbook that's free on our website. And these drawings that you see up here were taken from this book, and there's a lot more information in this book about this amazing process.
Located in the heart of the high-tech energy capital of the world, Reliable has the largest EDM job shop capabilities in North America, specializing nationwide in wire, RAM, and small hole EDM. Our commitment to our customers and our passion for technology has made us the EDM specialists.